We're going to move on to our electrolytic cells. Well, we're going to kind of talk a little bit more about half cell reactions first. It's important to understand that the voltages listed in the table of half reactions, the voltages listed in here on page whatever 7 it is, on the very right. These are reduction half reaction potentials because they're all listed as reduction reactions. But I need you to understand something, and I'm going to make an analogy. Has anybody been flying on a plane before? Has anybody flew in a plane before? Okay, so a good proportion of us. Perfect. Often when you're flying in a plane, are you traveling above the clouds or below the clouds?
Yeah, matters.
You're traveling typically, man, I got a hotness going on over here, holy. Typically you're traveling above the clouds. So here's the idea. What I want to do is, here's your perspective out the window of your plane, okay?
Straight.
Yeah, you have a window seat, and the window seat actually has a window, so that's awesome. Shh. I'm not done yet. Okay, let's try this. So there's a cloud line. That's literally the best I can do. Okay, and you can't see below the cloud line, but off in the distance you can see a city skyline. And so off in the distance you see, oh, there's a tower over here. Oh, and there's another tower over here. This is the best I can do, trust me. And then there's another tower over here.
It's like I'm there.
There's another tower over
Are we in Dubai?
That's terrible. Whatever. Okay.
Don't beat yourself up.
Yeah. What I want to know is, is it possible for you, you're flying past this city and you don't know anything about the city, you have absolutely no idea what's going on in the city, you don't know what those 4 towers are, but is it possible for you to tell what the tallest tower is? Which one is the tallest tower?
Yes.
Is it possible for you to tell how tall the tallest tower is? No. Is it maybe possible, with a little bit of trigonometry and some math, is it maybe possible for you to tell how much taller one tower is compared to the other?
No.
Yeah, you could totally do that.
What are you going to use?
But you don't know anything about your plane.
They tell you.
But yeah, okay, sure, whatever. They tell me, fine, that's fine. So let's think about this. This is a lot like what we have going on in here. It's not possible. I don't know if anybody knows a lot about physics, but voltages or cell potentials or potentials cannot be determined if you're comparing just one thing by itself. It is not possible to determine a voltage when you just look at one thing. What you have to do in order to determine a voltage is you have to compare one thing relative to another. That's the idea behind voltage, is how much electrical energy does this tower have compared to that tower? We don't actually care how much electrical energy this tower has, because it doesn't mean anything. As a whole, it doesn't matter how tall the tower is. The tower could be, 20 stories tall if it's really foggy out, right? And it's just the clouds are really low. Or it could be 5 million stories tall if you're on some alien world. But you don't care. All you care about is the difference between the two values. And so what you have to do, in order to be able to determine the relative height, what you have to do is you have to define one of these to have a specific height. Does that make sense? Let's say this tower here is what would be a nice kind of easy number to assign the smallest tower.
0, 5.
I would suggest, Jordy, what do you think would be the best value to assign? I would assign it a value of 0 meters. Now, that doesn't make sense, does it? No, that doesn't. But you know that this tower is not 0 meters tall. But what you could say, it's 0 meters taller than the smallest tower. Do you know what I mean? It is the smallest tower. So it's 0 meters taller than the smallest tower because it is the smallest tower. And then, now what you can do is you can take a look at the next tower and you can say, I don't actually care how tall the tower is, but I know this tower is 50 meters taller than the smallest tower. Does that make sense?
Where did you get that information?
Because you know, shut up. Don't poke holes in my argument right now, please. You know, for some reason you don't know how tall you are, but you know how far away you are from the object. Because one of these towers has a very definable clock on it.
Oh, okay.
And you know exactly how tall the clock is on the city that you've never been to with the towers that you've never heard of.
So we're flying in London.
Yeah. But does this make sense?
It's understandable.
So, okay, and then all of a sudden, as you're flying, the fog starts to not lift, but it starts to lower a little bit more, okay? So the fog starts to lower a little bit more, and all of a sudden, another tower is visible.
Wow. 37
You don't understand.
Go with it. Okay. So now, what kind of a height is this new tower going to have? It's going to be negative, I don't know, 30 meters, right?
Where are you getting
Negative
this
37, whatever. I'm making up numbers, but the idea of the relative heights, that's all that matters. Okay? So let's think about this for a second. So let's say you totally could just roll with the fact that we've already defined this to be 0. Or, what else could you do? You could redefine this to be the new 0. Now just roll with me for a second, stick with me for a little bit longer. If all of a sudden this was the new 0, okay, so minus 30 turned into 0, how much did we raise it by? 30 meters. So what do we have to do to every other tower? So 30 meters, 80 meters, do you know what I mean? But is the difference between this tower and that tower still 50 meters? That's all that matters. That's all we care about. Are we kind of okay with that ludicrous analogy?
Yes.
You hated it, but it's gonna hopefully help us.
Where did you get the analogy?
I just made it up. I've used heights of people in the past before, where if you have 5 people standing behind a bench and you can't tell like how tall exactly they are, but you can define one person to be 0, right? And then all of a sudden somebody else like shows up out of nowhere, you know what I mean? And then so you have to say, so then you have to figure out where's this person relative to everybody else? Do you want to define that as a new 0? Or
You should have done that.
yeah, it would have been awesome, but we're not gonna do that, so whatever. Okay, it's important to understand the voltages. So remember, those voltages listed in the half reaction table, they're measured just relative to each other. We had to define one of them as 0. Now we actually didn't have to define one of them as 0. What could we have, Denver, what did you want to define that first tower to be?
5 meters.
And then 5 meters, right? If you wanted to define one of these electrical potentials to be 5 volts, could you have? It's just that, and everything would be shifted up by 5 volts. Does that make sense? Okay. We use the hydrogen half reaction as the half reaction that all other half reactions are compared to. Can I get you to look at your table and identify the hydrogen half reaction?
0.
Should be the one that's 0 volts, right?
Yes.
Now, does anybody know why the hydrogen half reaction was defined as 0?
Maybe because it was the one that everyone else was compared to.
It was, yeah, it's
easy to use, probably. Easy to perform.
Basically every single person in the history of humanity has had access to acids at some points in time. And so if we're being honest with each other, the hydrogen half cell, the one that is 2H plus 2 electrons turning into H2 gas. This half cell, I'm not trying to say it's the easiest half cell to make in current times, but this was the one that everybody had access to a strong acid. Everybody had access to hydrogen gas. And so if we wanted these to be under standard conditions, does everybody remember what standard conditions are?
25 degrees Celsius.
25 degrees, so it's SATP, standard ambient temperature and pressure. So it had to be at 25 degrees Celsius, had to be at 101.325 kilopascals. So what that means is any gases in the equation had to be at 101.325 kilopascals. So this had to be at a pressure of 1 atmosphere. And then all the concentrations of aqueous solutions had to be what? 1 mole per liter solutions. So it was relatively easy back in the day to make a solution that was 1 mole per liter. That was something that was easy. Not everybody had access to aluminum, everybody had access to copper, not everybody had access to gold or something like that, but everybody had access to hydrogen. Okay, do we need to define the hydrogen cell as 0 volts? We could define any other half cell that we wanted to. So let's think about this. What if the reference cell changed? This is a really, really, really common
diploma question.
Diploma alert, diploma alert, I'm gonna start doing that now.
Don't.
Do you know why I'm definitely gonna start doing that now? Because you said don't.
That's a very
Yeah,
boomer.
because you don't like it. That is very boomer of me. Maybe I am 95% boomer. Oh, man. Okay, so if lead 2 plus, let's say the lead half reaction becomes the new reference half cell, we want to know what does the potential for the nickel half cell become. And so what I want to think about is what is the lead half cell normally at? Negative 0.13 volts, right? So negative 0.13 volts. If we want to redefine this as being 0.0 volts, right? What I want to ask you is what did we have to do to it to go from here to here? We had to add 0.13 volts. So what do you have to do to every other half reaction? Add 0.13 volts. So what did the lead used to be? Negative 0.13 volts. What did it change by? Positive 0.13 volts. Hopefully that makes sense. So everything has to change by positive 0.13 volts. So that nickel half cell, what's the old nickel voltage?
Negative 0. Wait. That's not good.
Nope, let's look at nickel. What is it?
Negative 0.26.
Negative 0.26, right? So the old nickel half cell, 2 electrons turns into nickel solid. So the old voltage was negative 0.26 volts, but now we're going to change it and add 0.13. So now this becomes, it's just a coincidence, I should probably pick different values next time, but it just happens to be negative 0.13 volts now. And it makes me mad that I picked that example, but that's fine. Another way of thinking about it is Nickel, is it above or below lead?
Oh, nickel. Oh.
Yeah, nickel 2 plus 2 electrons turns into nickel solid. And normally it's negative 0.26. So what you have to think about is, remember, the difference between these two is always the same. Before we changed the voltages, what was the difference between these two voltages? If you took one and subtracted the other, 0.13, right? Now that we've redefined them, what's the difference between them?
-0.
It's still 0.13, right? It doesn't matter what you define to be 0, it's always going to be the same difference either way. So I would like you to try a couple if that's okay with me, or if that's okay with you. Of course it's okay with me. Yeah.
What is
What are your thoughts on Wi-Fi? Just in general?
Thoughts on lawns? Are you very prominent about your lawn?
No.
I love it when people get off my lawn, as if that's what you're asking. No?
I think we ever answer boys.
No, Marcus, I'm a very big fan of lawn maintenance.
We definitely got our answer boys.
Yeah.
I have 20/20 vision, but even I can't handle this.
I got the dawn.
What was life like back?
What was life like back before the internet?
We were all alive.
Yeah. Oh yeah, you were all alive. Well, technically, I was alive, like when the internet was happening, right? It just wasn't popularized. God, that's a boomer thing to say too. Okay, so what you want to think about is the difference between the tin 4 plus and 4 plus.
We're on a mission.
Yep. So the difference between that and the nickel 2 plus, which is here, that difference has to be maintained. It always has to stay the same.
Okay.
So if we define this to be 0 now, what should we reduce this voltage by?
So then, if you want that, go minus
Negative
7.
0.15.
So if we reduce it by 0.15, then we have to reduce this by 0.15. Does that make sense?
Yes.
Whatever change you do to the reference cell, you have to change everything.
Walton, what age did you get married?
I was 30 when I got married.
I could probably do that.
How long have you been married?
I'm 32 now. So 2 years.
Epic game.
Were you alive in Jimmy Carter's presidency or Reagan?
I was alive for H.W. Bush because he was 88 to 92, and then Bill Clinton was 92 to 2000. And so I would have been alive for, who the hell was before?
It was Dick Cheney. No, it wasn't. It was Jimmy Carter.
Jimmy Carter?
It was Jimmy Carter.
Okay, all right. Yeah, I don't know. I would have been 1 when he relinquished his presidency, right? Okay, so the tin, it depends. What do you want to think about? Do you want to think about how much do we change it by? Or do you want to think about what's the difference between the two?
How much we changed?
How much do you change it by? Okay, so the tin, 4 plus 2 electrons turning into tin 2 plus. What was the previous voltage of this half reaction? 0.15 volts, right? So in order to change it to 0, what do we have to do to it? Yeah, you had to subtract 0.15. So what we're going to do is our nickel half cell now, we have to change it by 0.5 as well. We have to drop it by 0.15. So if it was negative 0.26 before, let's subtract, right? Subtract the 0.15. So it's going to be negative 0.41. Well,
Why am I having not a
does that I'm asking you, does that actually make sense? Yes. Whatever change you make to the half cell, you have to make that same change to every other cell. But remember, if I take this tower and this tower, so if I raise this tower by 10 meters and this tower gets raised by 10 meters, it's still the same difference, right? So you're still going to get the same cell potential in the end. Chrome.
Could you have it the other way around, where you
Yeah, we could define the nickel half cell to be 0, in which case we would raise it by 0.26. So we would have to raise this by 0.26. So this would be 0 and this would be positive 0.41. The difference between the two is the same, right? Yeah. So your overall cell potential, when you do cathode minus anode, the difference remains the same no matter what the reference is. Max.
So you did negative 0.26 minus negative 0.15.
Yeah. Because, okay, think of it not as like plus or minus negatives or positive. Think of, did we lower it or did we raise it?
We lowered.
We lowered it. So you have to lower this. And a negative large number is smaller than a negative small number. No. Like, what's a smaller number? Negative 0.41 or negative 0.26? Negative 0.41 is a smaller number, right? Because it's more negative than the other one.
All right. So don't do math. Just think about it.
Yeah, just use logic and reason. And if you have problems with that, you can come talk to me a little bit later. That's totally fine. What would the potential of a copper 2 plus reduction cell be if the reference cell was changed to be the reduction of bromine? So, what do we think? It's asking us what's the new copper voltage going to be if we defined this to be 0.00 volts. Did anybody get this? Yeah? Yeah? What was it?
The original one for BR?
Sure, what was the original BR?
I think it's plus 0.34.
Plus 0.34. That was the copper. That's the copper.
Oh, that's the copper.
Yeah.
VR is 1.07.
Yeah.
1.0. So this was 1.07 volts. And if we want to redefine it to be 0, are we raising or lowering it?
lowering?
Lowering it by 1.07. So let's lower this by 1.07, right? So it's going to become negative. 0.34 minus 1.07. And I don't know what that is.
73.
Negative 0.73?
Yeah. I don't have a calculator.
Denver, you don't have a calculator?
Just do it in your head, bro.
Yeah, just do it in your head.
It is
I'm
easy.
too tired. But
Me too, that's the thing.
Okay, this question, we're going to do the quiz 25 minutes left in class, right? That's kind of the standard of what we always do. So we got another 10 minutes, if that's okay with you. If the reference cell was the reduction of iron 2 plus, what would the reduction potentials of the following half cells be? So that's, I would like you to try this, right? So just keep going. If we take the iron 2 plus and we redefine it, I don't know what it was before, but we redefine it to be 0.00, I want to know what's this potential and what's this potential going to be. Go ahead and try it. Then we'll move on to bigger and better things. Yes.
Oh, wait, how much?
This question right here.
Oh, iron is
I think 2, and if it was this and this together, it would be 2 plus 1. Because you'd have to tell me, you'd have to identify that you're lowering and increasing the iron 2 plus, right? Iron 2 plus is negative 0.45. So if we're adding 0.45 to it, then we add 0.45 to the other 2.
Why?
You added both of the reactions.
You add it to both of the half reactions, and then we'll see what happens to the final reaction. Okay. So this one should be 0.79 volts now, right?
Yep.
So the new copper voltage should be 0.79, and then the new silver voltage should be 1.25, right?
0.79.
Wait a
Wait
second.
a second.
Yeah.
Wait a second. Okay, what
Keep going through that.
what was the iron 2 plus voltage before we changed it? Negative 0.45, right? And if we raised it to 0, then we gotta raise all of these by 0.45.
We just done with the wrong one.
That's okay. Did you choose iron 3 plus?
Yes.
Yeah, classic. Okay, what would the cell potential of the whole cell be? Now I'm wondering, which one of these is the cathode and which one of these is the anode?
It would be the EG.
Is what?
The cathode.
Cathode, okay? So this is our cathode, and this is our anode. Good? So the cathode, 1.25 volts, minus the anode, 0.79 volts.
That would be
0.46. Yeah. Did you?
It's the same difference.
it is too.
Right? Remember when I take those two towers, doesn't matter which one is the reference of 0, what's the difference between both of them? It's the same the whole time, right? So if a question is asking you, you can go the long way around, or you can just understand it's saying redefine one of these to be 0, and then figure out a cell potential. Well, the cell potential is going to be the same no matter who's 0. It's all the same difference, right? And that's all that anybody cares about. So you can skip all this gobbledygook and you should go straight to the cell potential. Yeah.
What's the point of this then?
The point of this was to show you that you don't have to waste your time on an exam if I ask you that question. But you could do this, and then you could do this, because you technically have 6 hours on the diploma exam, right? Wait, have I told you this yet? Please, for the love of God, don't take 6 hours on your diploma exam.
So like, what if you just...
Oh, what? You just wanna force the supervisors to be there for all 6 hours. Hey, oh my God.
Hey, we gotta do it, they gotta do it.
You don't have to do it though, right? Yeah. Oh, whatever. What? I had 3 hours to do it, but it was multiple choice, numeric response, and written all in the same diploma exam.
Yeah.
I don't know, but I took pretty close to 3 hours to do it. The only one I left early in was the English one, and I was like, I'm out of here. It's not happening, and I'm not going to do any better than what I already did, and so yeah, I just kind of quit. Which you should never do. But what? Yeah, me and English, no bueno. Yeah, whatever, it's fine. Okay, we are going to introduce for 5 minutes electrolytic cells, and then I'm going to get you to start your quiz. And then once you're done your quiz, if you want to, you can grab your if you were to finish it, because you totally could finish this quiz. I'm giving you 25 minutes, but you totally could have finished it in like 6 or 7 minutes for some of us. There's 4 questions. It's mostly written response, but it's just like answer all the standard questions I've been asking you to answer so far.
Is there a Forest Cup?
What?
Forest Cup? Is there
Yeah, there's a Forest Cup.
Awesome.
Yeah.
YouTube?
There's gonna be. You can draw a YouTube if you want.
I like
Yeah. Okay. When a cell has a negative potential, what does that mean?
Oh,
it's
it's
non-spontaneous.
It's non-spontaneous, right? Thank you.
I saw the video.
So if a cell has a negative potential, it is non-spontaneous. What that means is that there's not enough electrical potential energy in the system to get everything going, right? The electrons are happier with one than the other, and there's no way for the other one to steal the electrons. But what we can do, if you add some electrical potential, do you know what I mean by electrical potential? Voltage. If you add some voltage across those 2 electrodes, you can force the reaction to go. And the more electrical potential you add, kind of the more you can force this electron to go. And so here's the idea, is we're going to have an anode and we're going to have a cathode, okay? And what I want to ask you is that the cathode, what type of reaction is happening at the cathode? Is it oxidation or reduction? It's still reduction. All of our rules for all of our naming systems still apply. The electrons still go towards the cathode. The cathode is still the strongest oxidizing agent, or where the strongest oxidizing agent is. The cathode is still gaining electrons. It's still reducing something, okay? But what I want to bring your attention to, and this is going to be important for tomorrow, you need to hook up a power supply. Where do electrons come out of in a battery?
Both sides.
Nope.
Oh,
Do they come out of the positive or do they come out of the negative?
Out of the negative.
They come out of the negative. So you have to hook your negative terminal of your power supply to the cathode. The place where you want reduction to happen, you have to hook up the negative power in the negative terminal of your power supply. So the negative terminal must hook up to the cathode. There's all sorts of interesting things that we can do with electrolytic cells, including something called electrolysis. If anybody knows biology, lysis is the breaking up of something, and so electrolysis is the breaking up of something due to electricity.